This is lecture 14, example 1. This is another amazing timing diagram problem. The issue with this timing diagram problem is that it has a load instruction in it, and that's going to be what makes it even a more exciting problem. So let's just get into it. And I did expand the size of those instructions up there to make them doable, and looks good on this thing, so I think we're ready to do this. So we want to be fairly methodical about this, and there's a whole bunch of ways to do it. You can do it any way you want, just as long as you get the right answer. And so essentially I guess we're gonna fill in what we can on this thing. So I'm gonna go ahead and fill in this fetch and execute. So this is a fetch. This is an execute. These are just normal instructions. Fetch, execute, and this is a fetch. And check it out. This is a load type instruction. Fetch, execute, and then we have a write back. And this is going to be a fetch and an execute. And so this is ran out of instructions there. So we can delineate these quite nicely and then go look up the opcodes. And oops, I already made a mistake. So we're going to erase that. And okay, so I'm going to fill these in pretty fast, and then I'm just going to speed it up in the video. And I'm pulling these off one of the cheat sheets, and what I'm looking at is the 7 LSBs for each of these instructions here. I'm going to fill them up here. Okay, here I go. This is going to be super fast because I'm going to allow the video to do it for me. Okay, so let's do it. Okay, so I got those off the cheat sheet. By all means, I don't have those memorized or anything like that. And so let's look at these individually here. So the PC write is always going to be turning on as a function of, I will say, not the execute state, but the last state before the next fetch state. And so that means what we have is something special here. Essentially, we have a jog over here because this takes 3 instructions. It's not turning on an execute state. It's actually asserting in the write back state. And that's good for that. I think I'm going to jump down to the read enable down here. So the read enable is always going to be asserted. This is the program memory read enable. It's always going to be asserted as part of the fetch state. And it's a part of the fetch state simply because it's in that state. I already have a valid number, a valid address in the program counter. I am ready to, since the memory is synchronous, I'm hitting it with a read enable so I can actually get data out of that. But the PC is already there, and everything looks good for that. And so let's look at all these other instructions, see what else I got here. And so let's look at this is a memory read. And so let's look at a read write. Okay, so AUI PC is essentially it's taking program counter and adding something to it. So just to be sure, I'm checking my RTL and my cheat sheet. You can hear the papers crumpling as I do this. And once again, I'm not super up on what's happening in this. I always check my cheat sheet. Okay, so this is actually going to be writing a register, and so I need to turn the read write on. Looking good. I know this instruction is writing a register, so I can turn that on. That's good. I know this instruction. This is a jump instruction. It is. Wait, I better be careful of that. It might be writing a register. So I'm gonna pause on that one. I'm gonna check the spec because jump is a pseudo instruction. It's a JAL, and it by all means is writing a register, so I've got to put it in a register. Okay, so load immediate is writing a register, but I don't need to turn that load immediate on until that last instruction there, until the write back cycle, because it's not available before that. And then in the SL, the shift left instruction, it's once again part of the execute cycle. And so that's going to look good. That's what my reg write is doing. The key here is I wasn't sure about this, so I had to look it up, and it's this is actually a JAL instruction. J is a pseudo instruction. It breaks down to the JAL, and I'm going to say that looks good. If it has a problem, I'll come back and fix it. And okay, so memory write 2. So I can see that if you look at it, I'm always writing a register. I'm never writing memory in this thing. This set of instructions does not write data memory, so I'm never enabling the data memory here. Okay, and lastly, what I do need to do here is for this memory read. This is actually a read instruction, so I know it's not going to do anything for a while. But for the memory read instruction, what's going to happen is at the end of the execute cycle, that data is going to be available, and so I'm going to turn that on, and then what's going to happen at the end of the write back cycle is actually going to write that data to memory. And so that's the only time I'm accessing memory in this thing. It was this memory instruction here. These are programmed. This is program flow. These are just calculating something, so I don't need to worry about it. Okay, so that looks good. So we're half done with this thing. So next thing we want to do is the ALU function here, and so we'll start this off by saying we don't know what that is. And so the next thing this is going to do, AUI PC, it's going to add PC plus. Check it out. It's going to add PC plus plus a value. So I know it's adding. That's what I'm just stumbling on. So I'll figure out what it's adding in a second. It is for sure adding the add. I pulled this number off the schematic. Here I am, a shift right arithmetic. I got to pull that number off the schematic too. This happens to be shift right 1101, 1101, and then I have a JAL, and JAL instruction for a as far as the ALU goes, it's a big don't care. Okay, so that works there. Look, it's JAL is not using ALU, so it doesn't really matter what those values are. So next thing I'm going to do here is handle these instructions, and I believe this is going to be an add instruction because it has to add the base address plus the effective address, and that's good. And I'm setting it up to adds, and this one is going to be a shift left, so I got to look at my schematic. Shift left is 0001, 0001. Okay, and that looks good for that row. Now I think I'm going to do these rows together. Now this is a don't care, but after this point it does. We know what it's going to be. So AUIPC is kind of a weird instruction. It is going to choose a register on this thing, and so what I do is I look at what it's doing. It's choosing RS1. I'm looking at my cheat sheet, so I know I'm choosing RS1 to go into that top part of the ALU. And once again, that is going to be a 0. Once again, I don't have it memorized. Okay, so that's good. I'm happy with that. Now, so let's look at this here. ALU-B is the other issue. Is what this is going to be. ALU source B, and this instruction is adding the program counter to another register, and so I already got the register, and what I need is the program counter. And if you look at the spec, the program counter is being loaded into the 3 input on ALU source B. Okay, that looks good. Okay, so we'll keep going here. For this instruction, it is going to be, it's going to choose the RS1, and for the immediate value, it's going to choose, if you can see, SRAI is an I type, so it's going to choose the I type input. For ALU source B01, once again, I pulled this off the spec. This is the input for the I type because this is an I type instruction. Okay, so what else we have here? I don't care. Okay, this is the program flow control. These are both program flow controls here. And for the jump instruction. And so it's going to be a don't care. Okay, looking good. Now the load instruction is going to be, what am I going to do for this one? I'm going to add the immediate value associated with load, which is an I type, and the RS1 value. So this is going to be a 1, and it goes for 3, and this is going to be the I type. I type, I'm looking at the spec again. ALU source B for I type is 01, and that looks good. Okay, and then lastly, we can finish this up for SLLI. This is going to be a 0. It's choosing RS1, and the top is also looks like a immediate type instruction I type. It's going to also choose the same input as this one. The load instruction was an I type. This is also an I type, so I'm choosing that I type to be fed into source B. And I'm looking good with that. Okay, so PC source. PC source, it's whatever. I'd pretend like we don't know what it is there. But anyway, so these are just normal instructions here. And so that's going to be adding 4 each time. And I can keep doing that until I hit this jump instruction here. And this jump instruction, it's a JAL. So JAL is associated with the 1-1 input on that mux in front of the program counter, and that's why I'm putting a 1-1 on this thing. Okay, and so these are going to be PC source. It's just normal stuff here. This is a normal instruction. I can load as normal, and this is a normal instruction also. So essentially, I'm always choosing the next instruction, which is the 0-0 input to this mux, unless it's some type of program flow control. Okay, so lastly down here, I have the read-write select, so I don't know what that is. So this instruction, AUIPC, it's loading into register. This is going to be, it's going to choose the output of the ALU, which is connects to the 3 input of the mux above the reg file. This is going to pretty much be the same. And let's see what this is doing here. This is just a jump instruction. I'm not writing the reg file, so this is going to be yet another don't care. Not doing anything with the reg file for that instruction. And then we'll hopefully get something more interesting here. This is the chooses what data is going to be written to the reg file. For a load instruction, I need to write the data that's coming out of memory. So if I look at my cheat sheet here, I can see that DOUT2 feeds into the 1-0 input on memory. Okay, so that's very important. I wouldn't know that unless I looked at it. This is the idea is to get something out of memory and into a register. This is the path it takes. And lastly here, this looks like a normal instruction at the end there. And I think with that, I will say I'm done with this problem. So we cranked through it, made our way through it. Hopefully get better as you do more of them.